Hello to everyone who's joined already. We'll give it a few minutes just for all the attendees to populate, and then we'll begin. We've still got a few more people joining, so a couple more minutes. Just let everyone get in, then we'll start. One more minute, just a couple of extra people coming in case they've run to grab some lunch. There's a couple more people coming in now. I think we could probably begin, and then a few extra people might miss my lovely introduction. Thank you all for coming, and welcome to today's session. My name is Henry Hutton. I'm one of the talent success leads at HackerJob, and today I'm going to be moderating this event, which is lovely put on by CGI, and it's going to be about the hidden cost of technical debt. To go over, so what about the event today? We're going to be listening to a talk from one of the experts at CGI, and cover the main reasons for technical debt, as well as what you can do to avoid it. A few words about CGI to begin with. CGI are among the largest IT and business consulting services firms in the world. They have about 40 years of experience and continued business growth, supporting some of the UK's biggest and best brands across the commercial and public sectors, as well as helping to accelerate returns on your IT and business investments. And just a little bit of housekeeping before we get underway. If you have any questions during the presentation, please type them into the Q&A box in your Zoom control panel, and then at the end we'll go through a Q&A session with our speaker, who I will introduce now. We're going to be hearing from Doug Sykes, who is the Director of Consulting Services at CGI. Having started out as a software engineer, Doug has been a technical lead, a team lead, an architect. After joining CGI, Doug began working on multiple government projects, having moved into sort of a customer-facing position as Director of Consulting Services, where he now sits. He manages all customer accounts, including the teams that deliver the services to those customers. So Doug, over to you.
Thanks very much, Henry. So yeah, a little bit more about me just to start. I've been in IT for longer than I care to remember, in terms of how many years I've been around. But circa 2000 or so, I got very interested in sort of how IT and software is developed, and kind of went down a rabbit hole of agile engineering, and I'll talk about that a little bit more. And anyway, my journey has gone from, like Henry said, from software engineering all the way through to client-facing roles and whatnot. But I still like to code, although my developers don't allow me to do it, and they hate it when I do it. So I thought what I'd do today is just have a conversation around the hidden cost of technical debt. And the reason why I say the hidden cost, because everybody knows, or I'll go over what technical debt is, just because it's probably worthwhile touching on what it actually is. But then more to this presentation is actually what the underlying cost of that technical debt is, because there's cost to technical debt, right? But there's also an underlying cost that seems to have manifested itself within our organization, and I believe that's probably where other organizations are seeing it as well. But I just thought it would be an interesting topic to discuss, because while everyone knows things like technical debt, I don't think the true cost of it has actually been realized as yet. So a little bit more about CGI. We like to say we're the largest IT consultancy that nobody's heard about. We are large. I heard the other day in our financial year end that we are now 90,000 people globally. In the UK, we're about 7,500 people. And our tagline is that we're trusted to do complex things really well. And on that front, we separated into different business units within sort of the global infrastructure. So we're largely autonomous across geographical regions. So in the UK, we're about 7,500, 8,000 people looking after all manner of customers. And within that 8,000 people, we divided up into what they call sort of strategic business units, let's say. Each one of those business units looks after either a geographical region. So we'll have like a Scottish BU, a South BU, a West BU and whatnot. And each one of those BUs looks after that geographical region. And then we've got really specific business units where it doesn't make sense to divide that into a geographical region. It makes more sense to keep it as a industry sector or an industry vertical. So for example, I sit within the central government business unit, which looks after all our government customers from a central government perspective. So not local government, central government. And within that central government customer, we do quite a lot of legacy applications as well as new applications. So if anyone's ever used gov.uk web pages, there's a good chance that some of those web pages have been developed by CGI on behalf of the central government as our customer. And funny enough, that's what my teams work on, is they work on those central government web pages, as well as within the legacy applications. Some of that work is very rewarding. Some of that work is quite sensitive, so we can't talk about it. But suffice to say that on a day-to-day basis, my teams and other teams within central government affect the everyday citizen. And it's all about sort of turning government into a digital government. So instead of actually people having to interact or go into a government office to do something, simple things like passport application and whatnot, we've helped to move those kinds of things online. At the same time, the systems that run the back offices of government in places like the Home Office, in the courts and tribunal services, in HMRC, the tax guys and all that kind of stuff, we're also in there helping them develop digital applications to drive a digital government. So just to set the context, we've got a lot of legacy applications. We work on new world modern day applications as well. Okay, so to get into sort of what is technical debt. So on this slide, I just took this sort of technical definition right out of Wikipedia, and it's basically anything that you have to go back and do rework for, so it's the thing you have to do before you can do the thing that you have to do. So, if you get a change control notice or a new piece of functionality in an existing code base, chances are there might be something there already that you need to refactor or fix or redesign or look at before you can actually do that little change control or that new feature and whatever. So at its core, technical debt is basically having to do something before you can do the thing that you've been asked to do. Okay. So why does technical debt happen, right? So everyone wants delivery of software really quickly all the time. They're looking for the next release as quickly as possible. So I've kept this little cartoon in here, but basically saying that round wheels are more efficient, but like you can see that no one's got time for that. They've already got square wheels. Let's move with it. If you're too busy coding to design the solution, and you've got this attitude as we'll fix it later, then know that within every application you're building technical debt, and it tends to happen over time in all applications. Sometimes you just need to get stuff done and get it out the door, and then maybe come back and look at it later. The most relevant one of those recently, I thought I'd use an example. The most relative one of those recently was the passing of the Queen. So because we work in government and we work on government web pages, there are lots of web pages that had Her Majesty's courts and tribunal services. We had to go back in and change all of the hers to his. Now, that is a classic case of technical debt, because if we had been thinking about it, when we first developed the web pages, you would want to make that a field that can be changed dynamically, and therefore you only have to change it in one place, and it didn't have to be a developer if it was done in a sort of a static data perspective, and then every single website that had Her Majesty's a wording on it would have been changed automatically if you just changed it to His Majesty's. So it's simple things like that that technical debt can cause issues for. I mean, it delayed one of our latest releases, but at the same time, it's not too onerous. But there are other issues in terms of hard-coded things within applications and all that kind of stuff that can cause a lot of problems. Okay, so some of the causes around technical debt that just happen naturally is if you've got an old and antiquated system that's been around, and like I said, CGI, we've been around for 40 years, and we've been working with some of our customers for the better part of, especially in central government, 15, 20 years. Some of those applications are 15, 20 years old, and if you think about what applications looked like 15, 20 years ago, they didn't quite look like the picture on the left-hand side there, but you get the gist of it, right? So there's these old applications, they're sitting on old technology, they're sitting inside data centers somewhere. No one knows where all the bodies are buried in terms of the technical debt that's associated with that. We can use some tooling to maybe look at how much technical debt is inside those applications. But the reality of those applications is that they're working, they're performing a function. There's not a whole lot of investment in them to refactor them, to get that technical debt sorted out. But as they like to say in the classics, those applications are deployed on what we would call a burning platform, in terms of, we need to get them out of those data centers and into something more modern. So like a cloud-based environment, call it Azure, maybe Google Cloud, or even AWS, because, the actual hardware inside those data centers is coming to end of life and no replacement hardware is available. And there's an inherent risk in those, right? So in all software engineering or software development, if you want to look at that, zero-day exploits of old technology are being found all the time, and they can be affected and also compromised potentially. But at the end of the day, it's providing a service, right? So you can't just throw them away or shut them down. You have to either replace them with new or refactor them, rewrite them, modernize them, all that kind of stuff. And then the last, the picture on the right is just about, the pressure to increase productivity and have, which drives high technical debt, which drives low code quality, low productivity. It gives you low morale and motivation. Okay, so there's nothing new here, but just thought I'd call that out. So what do I think the real problem is, right? So if the tip of the iceberg is technical debt, what's underlying that? Like what is the hidden cost that I think we are seeing on a day-to-day basis, right? So the big problem is that we get to a point where these applications that are old are kind of become their own little islands within our organization and within the customer's organization. So there's very little knowledge share. The technology is very old. It discourages rotation of people off that project onto other projects or even into that project. The motivation of that team becomes very low. Security becomes an issue, like I said, and it's very boring, right? So how do we address this? Like, how do we solve this from being a problem? Because we've got this big sort of hairy gorilla in the room where we've got all these old applications. We need people to help us develop them and move them onto modern platforms, but the team is like sort of stuck in their ways and all that kind of stuff. And the first time this kind of came to light for me was when we had a person who'd been working on an application for like 15, maybe 17 years. He had been working on planning for his house for the better part of, for the better part of the last 5 years. He finally got planning permission and promptly retired so he could go and build his house. And he was a single point of failure on this application. So obviously we need to go find someone to replace that individual, to hire someone in. And the job spec came in and it's like, there's just no one knows how to do this job, right? And we can't take on a graduate, or we can't take on someone sort of quite junior to learn the system as they go, because it needs change and modernization in it all the time. So that hidden cost is like preventing us from putting new people who are at the beginning of their careers onto these old legacy projects to help modernize them and whatnot, right? So I'll put this line here: beware of the senior engineer with a ponytail, right? Because they've been around for a long time. They know where all the bodies are buried. They've got all sort of tips and tips and tricks to get their application released and out and everything like that. It's working fine and the customer's happy with it, but it hasn't been modernized in years and years and years. And you can't possibly put anybody that's got less than 15 years of experience in that specific technology on that specific application. To learn from that individual. And, to be honest with you, if you're starting out in your first and second year of development or in your career and things like that, you're raring to go. You're very keen to get stuck in. And the very first project that, if you do get put onto, let's say, for example, is an old COBOL project, and hopefully we don't have too many of those left, but we do have a few. That's not going to keep you, entertained for that long within our organization, or any other organization for that matter. Yeah, so it's the old adage, if anybody else touches this other than the developer with the ponytail, it's going to break something. So just let's leave it alone. But then you're driving up your risk appetite in those applications. So how do we go about solving this problem? Like, so how do we get to a point where we can modernize all applications in an ongoing way, right? So the buzzword for the last 10, 15 years has been around agile software development or agile engineering and all that kind of stuff. So I thought I'd just put this in here as a basis for what I want to talk about next. So if anybody knows that picture, it's from the actual Agile Manifesto software development website that was created in 2001. And if you can see, there are people sort of in the fuzzy background there. And that's actually the people that came together. It was Dave Turner and a few others that came up with this Agile Manifesto, which is basically, involving or focusing on individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. And in the context of technical debt, what this kind of means is being able to respond to change as it comes up. So if you develop something or build something, even if it's a prototype, iterating over that until it's gotten to a point where it's modern and new and fresh and whatnot. And I think from a high level perspective of software development, I think it's a really good approach. I really do. Unfortunately, I think what's happened is Agile turned into this, right? Or parts of this now. I got the scaled agile framework picture out because CGI happens to be one of the first global accredited partners of scaled agile. And I don't necessarily think there's anything wrong with scaled agile. But I think the unfortunate truth about agile software engineering is it spun up a cottage industry, albeit with billions and billions of pounds. And it created things like safe agile and lead agile and extreme programming and all these other kinds of things. but it kind of lost sight of the fact of what it was trying to do, which is basically working software over anything else, right? And fundamentally good working software. Oftentimes people will say working software is software that will work. But I think what I like to say is working software is also software that is relevant. So not only does it work, but it's relevant to the people that are using it, right? It doesn't frustrate them. It's a digital tool, not a crutch. People use all kinds of systems and absolutely hate them because there's nothing else there, right? And, if we're looking at things in government like digital by default and those kinds of things where they're talking about replacing fundamental services with digital-only services, they have to be fit for purpose. And I think a lot of this, these frameworks kind of obfuscate that a little bit, if I can say that. So Dave Turner, one of the guys in the picture in the previous slide, who was one of the sort of founders of that Agile Manifesto, actually stood up in 2015 at Google, one of Google I/O's conferences, and said that Agile is dead, and he blamed these frameworks and those kinds of things. So I don't think he actually meant that Agile is dead as a concept. I think what he meant was that at some point we lost that fundamental ability to respond to change, and complicated it by doing, putting all these frameworks around us. I often use the timelines of Agile as an example. So a lot of people think that Agile Manifesto was created and then Scrum happened, but actual Scrum or Agile Scrum came before the Agile Manifesto was created. So, just to put things in perspective, like I think Scrum's a really good way of doing things, maybe not for everything. Kanban and, those kinds of things can also be used, but in the context of project management, you need to use the right tool for the right place. And I think that's what I'm trying to get at is, don't think that Agile is the silver bullet that's going to solve everything with regards to software development. In fact, it can make things a lot worse if they're not implemented correctly and things like that. And just to caveat that, fundamentally, I don't have anything wrong against any of these frameworks and things like that. I think for me, when I first started and the Agile Manifesto wasn't a thing and Scrum hadn't become the big thing that it had, before that we had project management, and people used to use Prince 2 as an approach to software development. But as a software engineer at that time, I didn't know that Prince 2 existed. I just knew that I had to do software development, and I was given my tasks to do, and I did that. And I think in this day and age, we spend a lot of time telling developers that they need to care about Agile software engineering project management, where actually what they should care about is Agile, the Agile Manifesto and the implementation of the Agile Manifesto, and let the process or the project management around Agile development belong to the project managers, and let the project managers use it as a tool, and let the developers use their their tool sets, which is the patterns and technologies, in order to develop good working software. Okay, so what is our approach, right? So one of the things we've started to do on our legacy projects, and also, on our modern day projects already, everything is code, right? So from infrastructure all the way through to deployment, everything is code. So on some of the more modern ones, we only stand up, for example, build environments, test environments, and those kinds of things on a commit to a Git repository, right? So there's a listener sitting, waiting there to listen for a code commit. When it happens, it will spin up the actual development test environment, run all automation tests, check that code coverage and all the security aspects are done, and then deploy that application to live. Currently, we deploy to live about 8 or 9 times a day, depending on what the application is, and then it shuts everything back down again. So that's the approach to modern day practices. Now, what are we doing in terms of our legacy applications? Well, we're trying to do that as well, right? We're trying to wrap those legacy applications around in code. We do a lot of different approaches in terms of those applications. Some of those applications get decommissioned, they get replaced by new ones. Some of them get refactored or modernized into a modern technology set, and some get sort of containerized and treated as a black box and moved across. But in so doing, we're looking to reduce the technical debt and whatnot. And then on the right there, I just put in living documentation. So we use tools like Confluence, sometimes SharePoint, sometimes Ensemble, to put our documentation into that, into those areas. And I'll talk about our document approach a little bit. So what we do is we make sure that our documents naming standards are all the same across all projects, so that if a developer moves from one project to another project, regardless of whether it's a legacy project or a modern day project, the documentation set is the same. So for example, we'll have like a 0500 software engineering document, which will have a sort of the ways of working, principles, how to set up an environment, where you can get your self-service stuff from, all those kinds of things, that will allow anyone that is new to the project to actually be to use self-service, as opposed to actually having to go to a senior software engineer and talk to them. And it's not to say that the senior software engineers don't help, but they will. But you know, the premise is that if you can join a project, a new project, and start delivering working software within the first week, then you know it means that you've got very little technical debt in that application. And I just put that little picture in there because the reality is developers is, you know, if your documentation isn't living, then they're going to go hit, I don't know if you can see that, but they'll go hit Stack Overflow before they actually look at their official documentation. And that's just the reality of the situation. So we're trying to, on a day-to-day basis, to move our legacy applications incrementally into a sort of a more modern world, and having a patterned and a singular approach to software engineering across the piece. And what that allows for is for us to rotate developers through different projects, and them having the same experience on all those projects. And all that changes is the domain. Potentially the technology changes as well. You notice I haven't spoken about, having a singular technology approach like .NET or a singular cloud approach like AWS or Azure or whatever, because we're a consultancy and we have multiple customers. It all depends on what our customers have already, and also what their stated strategic goals are going forward. So we can't afford to paint ourselves into a corner of saying, oh, we're a .NET house, or we're a Java house, or a Golang or Python, or whatever the case. We need to have a patterned approach, or a template to actual software engineering. And that helps us reduce technical debt inside those applications. And like I said, allow for rotations. Okay, so one of the things we look to do as early as possible in any applications these days is automate early. So we automate all the things. Like I say, the more test automation and those kinds of things, pipeline automation and everything, release automation that you can do, the more time you can spend on actually developing functionality for the customers and making sure that you're reducing your technical debt and all that kind of stuff. The one caveat to that is the picture on the right is, you spend sometimes automating things is not really the best way to go. If you're spending more time doing automating than actually developing software, then you need to be careful of going down that rabbit hole of constantly fiddling with automation and making sure that it's 100% fine. I've seen that happen before, where a simple piece of software doesn't need to be automated indefinitely until the end of the world. So just look to automate, but just bear in mind that can lead you down rabbit holes as well. And then we've looked to introduce patterns. Hopefully these aren't any what is the word I'm looking for? The unknown to everybody. So the solid principles we look to institute across all our software engineering capabilities. That's one of the things that when I'm talking to people or interviewing people that I like to ask about, to ensure that people understand what they are. And then the one on the right is, obviously don't repeat yourself. The drive principle of, once you've done something once, don't do it again. And don't look to reinvent the wheel every single time you see something. One of my favorite sort of waste of time kind of stories is way back in the day when Java was first a thing, well, not first a thing, but it was after a few years, and Log4j had come out. So Log4j, for those who don't know, is a sort of a logging, so the tool that, or library that you can use when you're writing Java code, just to log everything. Really good tool, really works really well. One of my devs at the time decided that no, that wasn't fit for purpose, and wrote his own logging library. And while it worked, it was nowhere near as functionally rich as Log4j was, and no one was ever going to adopt it other than himself. So he spent the better part of 6 months writing this thing that was never ever implemented. And so using existing tools to actually further yourself, further your application is the best way. I like to say that I'm a lazy developer. The very first thing I do when some task is given to me is to go and see if it's already been done within the application. Can I copy that code or use it in its entirety as it is? In other words, extend it, or does it exist as open source on Git somewhere? And can I use some of that in my code and whatnot? I think that's not a bad approach to take, because chances are someone that's put something on GitHub has made sure that it's quite good. All right. And then the last thing I wanted to touch on was, so what's the nirvana, right? So what are we looking to achieve? Like, what are we trying to get to? Like, where is a situation where we have no technical debt? And I saw a talk a while back, and I can't actually find it anymore, but the person that was doing the presentation was talking about how you should never, when you're writing components or building components, things like that, you should never build a component that would take you more than a week to completely rewrite. So if you had to have that component almost finished, let's say, or it is finished, and you throw that code away and you start from scratch, if it takes you a week or more than a week to rewrite it, then you need to simplify it. But if you can rewrite that code component within a week, that kind of means that you've never got more than a week's worth of technical debt inside your application, right? Because you can literally throw that component away and rewrite it within a week. That's probably an oversimplification of what he said and misrepresentation of what he said. But that's what I like my teams to try and strive for, is that whenever they're building a new component or something like that, then they should try and keep it to within something that they can code within a week from start to finish, right? And then to hop back to the point around living documentation, one of the things that came out of the Agile Manifesto is that, let's just code, let's not worry about documentation. And if you read between the lines of that manifesto, while they think that the things on the right are important, they favor things on the left. And a lot of, I think, software engineering teams fell into the trap of, we'll just codify everything and not worry about the documentation. And I think in today's world, having living, breathing documentation that people can use and is relevant is key to doing your day job as someone new on a team. And that reduction of the potential of not being able to find somebody else to come into the team and do their job on a day-to-day basis, and be really disruptive, because as developers come into the team and as developers leave teams, that can lead to a lot of disruption, and we're trying to reduce that, right? And that's it, right? That's the end of the presentation. I hope you found that useful. It's something that I spend a lot of time thinking about. And if anyone's got any questions, that'd be a good time to ask.
Absolutely. Thanks very much, Doug. Very insightful. We've got one Q&A in the Q&A. So for those that joined late, if you have any questions, please do feel free to pull up the Q&A panel on Zoom and type them there. We've got one already from Emmanuel, who wants to know, do you also collaborate with private organisations? Was it sort of, I guess, mainly government?
So like I said, we've got multiple business units throughout the UK and also globally. So we do a lot of stuff with private industry, especially in the finance sector, retail as well, and a lot with local government. Just my area of influence over the last while has been been in government. I've done a lot of stuff in retail over the years with supply chain management. So looking at things like point of sale systems, warehousing applications, purchasing applications, written a few. We also, like I say, look at financial institutions. So we spend a lot of time with banks like HSBC and the like. So yeah, so we're a consultancy. We don't rule out anybody. I mean, in fact, CGI is a Canadian, the head office is in Canada, and albeit in French, the CGI stands for consultants to government and industry being the private sector. A lot of people think it's got to do with computer graphics, CGI, but it stands for consultants to government and industry.
Wonderful. And they've got a couple of questions coming through now, and I've got a couple as well to ask you as well. So the first one we've got, as with all teams, we have to balance delivering new stuff and managers users want and addressing the technical debt we've amassed. How do you manage the balance between new demand and need to address old technical debt?
Yeah, I mean, that's a very good point, and I think a lot of that comes down to the product owner. A lot of our product owners in our environment are actually on the government side of the fence, on the customer side of the fence, and it's kind of explaining to them or letting them know that technical debt is a natural byproduct of software engineering, and there should be a specific, at least a little bit of time linked to looking at resolving some of that. In some cases, it's easier to do than others. I mean, a lot of it comes down to funding and whatnot. But we tend to set aside a certain percentage of time in sprints on certain projects to look at technical debt, especially on older applications that are going through a new renewal process. We also tend to do quite a lot of not a lot of, but we tend to look at doing spikes, technical spikes, in terms of, for example, if a application, funny enough, it's happening right now, an application is running on a really old version of Java, and we can't upgrade it because of the fact that it's running into an Oracle old school database. But anyway, we're looking at the impact assessment. We do an impact assessment of what it would mean to upgrade it to the latest version of Java, or the latest sort of, let's say, not the latest, but the latest stable version of Java. And we'll do a technical spike and an impact analysis on how much work that would be. And then we'll present that to the customer and say to them, okay, it's going to take us, let's say, 3 months to refactor all of that. And what that would mean is a code freeze on releases and not ideal, let's say, but at least that gives us the opportunity to actually resolve that technical debt in terms of the old version of Java. What we'll also do in that process is we'll document it. So if there are any other applications, for example, there are other applications that are running an old version of Java, that we can take the key learnings from that in our documentation into the next project and do that modernization potentially in a much faster way. So yeah, that's what we tend to do.
Thank you. And then I guess a very interesting sort of real world question from Neil. He's saying his CEO loves looking at the actual monetary cost. How do you go about putting a price on your technical debt?
So we actually have a tool, funnily enough, called Cost, which is a set of tools that will do an analysis of your application and tell you how much. It gives you a dollar amount of how much technical data you've got in your application. I mean, that's the bog standard answer. A Cost is not it's not a CGI tool. It's a third-party library or license tool that we use. So you can use it on any sort of technology, I suppose, or any application to see how much technical debt you have in there. I mean, we tend to use that in terms of how do I factor in the technical debt part of the application. It's a really difficult one to answer, because the technical debt is oftentimes a result of something that we've done. Now, where does the responsibility lie to resolve that? I mean, I always like to come back to the electrician sort of example where, I don't know if anyone's ever had an electrician in their house, but the first thing they'll tell you is that the last electrician did a terrible job, and there's so much work that they have to do before they can actually do the work that you've asked them to do, and that will be at your cost, right? It's like your house is about to burn down, the electricians are so bad, so let's redo them all. And the same can apply to software, right? It's like, well, who wrote this code? It's terrible. We need to refactor it all and fix it. But in our case, sometimes it's us, right? So we tend to take a bit of a pragmatic approach to that, especially in government, and also in modernization programs. It's inherent that you will potentially resolve technical debt. We do a lot of design and analysis upfront, discovery phases and alpha phases and proof of concepts, in order to try and reduce the amount of expenditure when trying to resolve that technical debt, and making sure that there's actually value at the end of it. I like to say with everything that we do, that we should look back and measure, because oftentimes people don't see the benefits of the resolution of technical debt. Because you're not effectively changing functionality within the application. You're effectively just making the application more robust for future enhancements and whatnot. So that can be something hard to quantify when going to the customer. And sometimes technical debt is okay. It's not the end of the world to have a little bit of technical debt in your application. And sometimes it's worthwhile leaving well enough alone, and not to just factor that cost in of redevelopment just because it feels like it should be refactored.
Absolutely, yeah. And we've got a couple of CGI related questions. For those of you who are asking about roles, there are a number of open roles at CGI. We'll get a link posted in the chat to their careers page, and we'll sort of finish with some notes on that as well. But someone's asked, are your development teams sort of long-term on-site embedded with clients, or centralized in CGI premises, or sort of a hybrid sort of approach to projects you work on?
I love that question. It depends. So I'm working from home at the moment. We have CGI offices throughout the UK. Our main head offices are in the Walkie Talkie building in Fenchurch Street in London. We've got offices in Reading, in Leatherhead, in Wales, in Bristol, in the Midlands, in Solihull. We've got, if that's the Midlands, I apologize if I'm not, I'm geographically challenged. We've got offices up in Scotland. We've got offices all over the place. But we've had this hybrid working model for quite a while. So a lot of our guys work from home a lot. It doesn't make a whole lot of sense to CGI to make people spend 2 hours sitting on a train to get into work for a commute, to when they could just be at home and whatnot. But what we do is we use our offices to meet people. I have some people working for me that are quite new to the organization, that haven't met another person within CGI. So, we try and get people to come into the offices in localized places where we can have maybe a team meeting and all that kind of stuff. It's harder to do now than it was in the past because of the sort of disaggregated nature of the work that we do. And so I've got some people that work for me that are in the north of Scotland, some in Manchester, some in Liverpool and whatnot. So I tend to go and see them rather than having to them come into our offices, although there are offices available. There are certain projects that we work on that are secure, hyper secure, not technically too much in my area, but there are opportunities in like sort of space defense and intelligence where they're working on with the Ministry of Defense and this this Galileo satellite program and those kinds of things where those applications are air gapped, and that would require people to go into the offices. But then we tend to hire people from that geographical region. So in Leatherhead, once again in the Midlands and whatnot. And then there are people that just like going into the office. So there are offices available, like I say, in Reading and whatnot, which are quite nice and all that kind of stuff. So we take a sort of a pragmatic view to it. We are looking at it all the time in terms of ways of working, what the best ways to work are and all that kind of stuff. I mean, I think working from home is great, but for someone that's new into the organization, especially in a large organization like CGI, you can get put into a team and it can feel quite insular, which is great. But culturally, how does that affect the individual? So like I say, for my team specifically, I tend to try and get people together in pockets of geographical regions around the country. but work-life balance is very important to CGI, and we have a thing about bringing your whole self to work. So in other words, don't think that the minute you leave the door of your house and move into your office kind of thing, we don't believe that you leave all your problems at the door, right? You everyday life happens to people, and therefore, having that kind of mental health kind of approach to software, to working in CGI is very, very important.
Absolutely. And then going back into technical debt, someone's asked, would you advise a business case put together to convince an organization to address technical debt as a project prior to starting further dev work, or would you recommend sort of baking in technical debt removal into sort of future projects?
That's a good question. That's a very good question. I suppose it depends on the application itself, right? If you've got a legacy application that's sort of creaking at the seams, then you kind of have to, the business case for refactoring it or modernizing it will inherently have the technical debt aspect in it, right? But when you're starting out at the beginning of a project, the principles and practices that you put in place in terms of reducing technical debt, allowing for sort of loose coupling of components, using modern technology practices like microservices and all that kind of stuff, should in effect, if they implement it correctly, keep your technical debt to a minimum. But having a nod towards it, I suppose, is fair enough. As something within the application that there will be refactoring no matter what application you're in, right? So yeah. Would I quantify it at the beginning of a new project? I don't think so. But on a legacy project, I definitely put that in as something. Yeah.
Absolutely, yeah. And so you've touched on a little bit in some of the other answers here. How do you manage technical debt and deadline expectations with clients and when to remove them?
Another very good question. Deadlines, going to say something controversial here, but deadlines probably are more important than technical debt. Is that true? I mean, I know this has been recorded and probably be held against me in perpetuity. But like I say, right at the beginning, getting stuff out of the door, especially when it is critical. In government, there might be something like legislative changes. There might be a security issue that like a zero-day exploit that's been found or whatever, and something just needs to get out the door because there's a vulnerability. So I would prioritize that over any technical debt concerns that we have, and just get it working. But then put something in place to resolve that after the fact. But yeah, it is a constant weighing up exercise. And honestly, a lot of my dev teams now sort of resolve technical debt as they go. If behind the scenes, under the covers, it's like a cost of doing work kind of thing. Especially on the modern projects, there's a constant look at sort of, I mean, even if it's sort of upgrading to the latest libraries and those kinds of things, although a lot of that is automatic these days, there are some components or some applications that we work on where that's not automatic, and that kind of needs to be looked at, and using tooling like white source and or black duck and those kinds of things to actually keep in line with that is something, once again, that's just a cost of doing business.
Yeah, absolutely. And then we've got one question asking if you could give an example, sort of money-wise, about some hidden costs so they can have an idea of sort of the size of the problem and what it is.
Okay, I won't talk like sort of pound terms, but what I can talk about is, so I mean, we're a consultancy, right? So our time goes out at a day rate of X, Y, and Z. When you're talking about specialist senior software engineers that have to be replaced by another senior specialist software engineer, if that person resigns or whatever the case may be, then that can be a very expensive person, to build to your customer. And that's kind of what I'm talking about is in the hidden cost is like, well, it would be really, really good if we could put some sort of junior people on there that can learn as they go and effectively be charged out to the customer at a lower rate. So reduce the cost of actual software development by using people that are sort of at the beginning of their careers and potentially are not as expensive as those senior software engineers. And the old legacy applications that require 5, 6 senior software engineers are very expensive to maintain. It's like the cost of doing maintenance. It's like the older your car gets, the more costlier it gets. The older the application gets, that cost base doesn't get any less. And what we want to try and do is reduce that cost base to almost nothing over time for the customer. So that's kind of an example of what that means. There's the cost of actually refactoring code to reduce technical debt, but there's also the cost of maintaining old legacy applications with senior software engineers, which could be deployed onto other more complex applications to do more technical work over time. So, there's a double efficiency hit there.
Yeah, completely agree. And then with regards to technical debt and agile, can you provide any examples where sort of an agile coach or a scrum master has helped a team or provided them tools to empower the devs to take on the issue of technical debt?
Mm-hmm. So this actually wasn't the example I'm going to use, a real life example. It wasn't actually at CGI. It was before CGI, but I've seen it before. So I've seen it since in CGI and whatnot. But when originally I was working on a fraud detection application, I was actually an architect on that, not a client-facing director kind of thing. And from the time that a customer requested a change till the time that change was released was 2 years, if you can believe that. Which is way too long, right? Our release cycle was once every 8 months, and the change backlog was massive, and we got to a point where it was just untenable. So one of the Scrum Masters at the time was quite new into that consultancy, funny enough, and actually just said, look, let's take a point in time, and we're not going to release for the next 8 months, and we're not going to work on new functionality for the next 8 months. What we're going to do for the next 8 months is actually get to a point where we take a truly sort of agile approach to software engineering. And it was one of the first times I'd ever been involved in something like that, where a lot of agile processes and practices come around in terms of what I call agile, which is like waterfall with a little bit of agile on the end of it. So, and the example of that is that you might do your software development in a sprint, but then you do your testing in the next sprint, right? And then your UAT in the next sprint. And what tends to happen is that fundamentally blows back on the software development team, because when they were in the next sprint, right? So they've done all their software development. Now they're doing their next sprint of software development. All the testing bugs, and not that any developer ever develops a bug, right? But anyway, affect that sprint. So you get into this scenario where instead of doing the new functionality in every single sprint, you're actually just fixing the bugs from the previous sprint that you created, and it creates what I like to call agile churn or wagile churn. It was fundamentally the first time where someone said, no, when we end a sprint, that is working software. It's been tested. It's ready for release, right? That's the fundamental premise of Scrum. And we took a little bit of pain for the first 3 months, but after 3 months, everybody kind of got on the same page. And then after that, albeit really small pieces of functionality were started to be developed, but they were developed to the point where they were ready to be released.
Yeah.
And the Scrum Master, I won't mention his name, but he fundamentally drove that principle into every single team. And I brought that across into CGI. So, when we're doing Scrum or whatever the case may be, if someone says to me, oh, we'll test what we're doing now in the next sprint, I was like, no, that's not Scrum, that's not Agile. What it is it's pushing the problem down the road. So make sure that when you're sprinting and doing Scrum and those kinds of things, that you're actually fundamentally paying attention to what it is that Scrum is, right? Which is to develop working, releasable, shippable software at the end of every sprint.
Yeah, completely agree. Yeah, and then more a statement, Bill. Interesting to get your thoughts on it. Someone said that I think DevOps reduces technical debt because the code is updated. When the new piece is deployed, it just updates the existing software.
Yes. So DevOps is an interesting one, and the reason why I say it's an interesting one, because fundamentally within CGI, we being a 40-year-old, 90,000 strong organization, there's some very strong opinions from all over the world in terms of what software engineering is and what the sort of separate disciplines are and all that kind of stuff. And I think one of the things that's kind of been lost in translation is what actually DevOps is. And that kind of, it's a little bit scary for me. Well, not scary, but it's a little bit of a disappointment to me. So when I first started my career, I'm not going to say when, but it was when people still saw in black and white, let's say, there was no concept of a front end, back end, database, infrastructure engineer, all that kind of stuff. You literally did everything, right? So, if there was a Linux script that needed creating, you wrote that. If there was a bit of SQL that needed writing, you wrote that. If there was some code that needed writing, you did that. If there was some front end stuff, you did that. If there was a router that needed installing in the computer room, you did that kind of thing. So you became this sort of by default full stack engineer, let's call it. I mean, and I'm not trying to underestimate the disciplines of front-end engineering or user research and all that kind of stuff. But everybody kind of found their way. So while some people would gravitate towards SQL and some people would gravitate towards, let's say, COBOL, or some people would gravitate towards infrastructure engineers of Linux or whatever the case may be, they'd have a holistic approach to software development, right? In the 2000s, it became, I'm a front-end developer, I'm a back-end developer, I'm a database administrator, I'm a database architect, or whatever the case. And those disciplines became quite narrow. And the principle became, oh, it works on my machine, not my problem, I'll throw it over the fence, give it to the infrastructure engineer, it's their problem to deploy it. Mm-hmm. And I think DevOps kind of, when they come out circa 2011, somewhere around there, it was to try and bridge that gap between development and operations again, and give everybody a sort of a more holistic approach to software engineering. So, but since then, it's become like a role where I think it's more a discipline. Everyone should have some kind of DevOps capability within themselves. They should understand what it means, and 100% right. Everything is code. That reduces technical debt, but once again, what I've seen happen in certain circumstances, and we've had to take remedial action, is where they have said things like, "Oh, my software is working as a front-end developer. I've pushed it into the pipeline. The pipeline's falling over. It's a DevOps problem," and that fundamentally worries me, because that's not what DevOps is about. DevOps isn't replacing infrastructure engineers. DevOps is there for everyone to actually learn from each other and understand how the entire application estate is deployed, and taking responsibility for your software and whatnot. And when people push the problem back down onto DevOps is when I start to get a little bit worried. Fundamentally agree with that statement. DevOps is there to automate all the things.
Perfect. And then just to finish off, we've got two questions around conversations with clients. One is focused around if there's a cost of doing business, obviously as a consultancy, how do you allow time for resolving technical debt on a project, even if you don't actually charge for it? And the other is around when clients try to reduce the number of consultants assigned to reducing the technical debt.
Mm-hmm. Yeah, so I mean, in terms of the costs and things like that, we've got different mechanisms. Like I say, we put aside some time on each sprint, which is non-billable time, to resolve technical debt and those kinds of things, especially when we've done something that is, we've just had to get something working, or if it's proof of concept that gets out the door, and we will probably put a percentage of their time to non-billable work. Don't let anybody that's higher up than me hear me say that, but we oftentimes also, when we're bringing in graduates and those kinds of things into the project when they first start, we allow them to book to non-billable time for the time being whilst they're getting up to speed. And a lot of what we like to look at in terms of furthering them is actually trying to get them to resolve some technical debt as well, if there is any. There of course will be, but a bit, new set of eyes on old piece of software, is invaluable. And what was the second part of that?
The second part of that is when sort of clients want to reduce the number of consultants.
Oh, right, yeah.
On technical debt, how do you deal with that?
Yeah, so I mean, we have to motivate why we have the amount of people working on the projects that we do have on. And it's something we constantly look at. So it's not really a problem that I've come into. In terms of, I mean, not to go too deeply into it, but a lot of the projects that we do are time and materials based. So the amount of consultants can go up and down accordingly, according to the amount of work that's in the backlog. On fixed price things, when we're trying to hit milestones and payment milestones and all those kinds of things, then it tends to be a little bit easier in terms of, well, as long as you making your margin, then you can have as many people as you like on there, although you want to run it as efficiently as possible. But yeah, in time and materials based applications, a customer might say, look, there's not enough work in this backlog to justify having 10 people on it, or whatever the case may be, 2 Scrum teams. Can you reduce it down to 1? Then we'll look at that and evaluate what that actually means, and whether it's physically possible, and will that impact deliverables and all those kinds of things. But technical debt normally doesn't come into that conversation, to be fair. Yeah. That's more about functionality and feature development.
Yeah. Great. Well, thanks very much, Doug. Very insightful talk. Thanks for answering everyone's questions. Just to finish off for all the attendees, so the team at CGI are actively hiring right now. And as a follow-up, like I said earlier, we'll provide a link to their career page where you can find a list of open positions from software engineers to data and others, as well as their benefits. And if you're interested in career opportunities with CGI, please register via the form in the email you're sent, and we'll come back to you with all of the openings that fit what you're looking for. And again, Doug, thank you very much for your time.
It was my pleasure, and thank you very much for listening. I really enjoyed that. If anyone wants to look me up, I'm only on LinkedIn. I'm nowhere else. But yeah, if you want to reach out and have a conversation with me about anything, really, just ping me on LinkedIn.
Cheers, everyone.